Hello, hello.
Hey everyone.
Hey, everyone. Thanks for tuning in. Great. Just checking that everything works. Seem to be good. All right. Yeah. Hi, everyone. Thank you for joining us here today. Excited to kick off this second workshop of our 402 PayTech Hackathon. As you may know, there is a $42,000 prize pool to be distributed at the end of the hackathon. So if that's not enough reason, I don't know what is. But today we'll actually be talking more about agentic payments with Crypto.com's AI Agent SDK. Like last time, your host is Rick here, who is in the call with me, who is the blockchain innovation engineering lead over at Cronos. Also, don't forget there is a Q&A section at the end of this workshop. You can drop your questions in the chat, and we'll answer as many as possible we can at the end. After the workshop, just like last time, we will upload the entire live stream to our YouTube channel so you can rewatch it and drop all useful links on X as well. I think that's kind of it what I wanted to mention during the intro. So I think Rick, if you're ready, please take the stage.
Okay. All right. Thanks for the introduction. Yeah, I'm excited to walk you through today's workshop. I don't know if a lot of you have been here in our first workshop, but today what I want to walk you through is something that most of you are very excited about. I personally, I'm very excited about agentic payments, especially in the context of x402. So yeah, I hope this is insightful and helpful for everyone. Before we get started, there's a few things that I want to walk you through. Let's start maybe with a quick agenda of the items. So, we're going to start very briefly with X402 recap. And then, next I want to walk you through A2A and agentic payments. So for those of you who don't know A2A, it's a protocol that has been extended by Google. It's actually really good when it comes to creating discoverable agents and systems and making them talk with each other, especially when it comes to paid APIs and stuff like this. Which brings us to the third point: discoverability for paid resources. I want to quickly show you also the agent card and resource metadata, which is widely used in the A2A protocol. Some examples when it comes to x402 in A2A workflows. I also want to give you the architecture on agent, how the whole architecture flow works between agent, resource, and facilitator. And I've also prepared a end-to-end A2A x402 demo, which is going to be shared with you after the call today. So we'll make this end-to-end example app available in the x402 example repository, which we have been sharing with you already since last time. Have a look at some design patterns when it comes to A2A and some best practices. Again, share the resource and repositories and relevant repositories. And then at the end, spend some time on questions and answers. All right, yeah. Before we get into it, there's a a significant actually update. We just made our x402 client. We enabled x402 client support for Python. So anyone building, on Python, especially when it comes to using agentic frameworks, they typically work best. I know that it's kind of subjective, but most agentic frameworks nowadays feel very comfortable in Python environment, and so it was a compelling opportunity for us to extend the Crypto.com facilitator client also for Python. So anyone building, in Python, and you will see that in a minute because we have two examples. Again, we're gonna have a look at the resource service, the same one that we used in the previous workshop, but this time we also have an agent service running in Python, and so I think it's a good time to review those two implementations. Now, hopefully, it's going to be helpful for you as well. Okay, so what is the context and what is the motivation of using agentic frameworks? So first of all, the underlying problem that we're trying to solve is, that most payments in the Web3 world are using the assumption that there are humans, browsers, and wallet pop-ups being used. But obviously, agents tend to operate in a very autonomous manner. So, they wouldn't have, or to a certain extent, nowadays we have MCPs and there's all sorts of options to make it happen. But yeah, we came to the conclusion that agents need programmatic discovery and also must decide when and what to pay for. So yeah, that summarizes really our context and motivation. We talked about this in the last workshop, but for those that didn't come, and I think this is pretty self-explanatory for most of you. But yeah, you can think of x402 as an HTTP native payment system that uses standard HTTP semantics and the 402 status code, which stands for payment required. And then remember that we think of payments as stateless, on demand, and verifiable. And so no browser, no wallet, and no user interface must be required. So, in other words, you can think of x402 as a means to turn HTTP resources into machine payable services. Yeah, next slide, from browsers to agent. So what you can see here is some different workflows, and we're going to have a look at it in a bit. But generally speaking, in traditional x402 flow, like the one that we used last week in last week's workshop, you do have a browser that calls an API, that calls 402, that calls a wallet, that uses retry, and then we use the 402 status code payment required. In the context of agentic x402 flows, you can think of the agent being sort of the browser, because the agent is the part or the system that maintains, the responsibilities that were previously encapsulated within the browser. So a user would use the browser to make the API request, and then the 402 status code is being returned, and then that triggers a wallet request, which in the context of the agent workflow, we wouldn't have a wallet in the browser sense, or in the traditional sense of being signable from a browser, but we would have an agent that has authority to sign, through his own, let's say, keys, and then essentially do the same flow that we are, already familiar with. And that's it in a nutshell from a comparison perspective. And I think some of you know differences already, but I think it's still interesting to line them out. So again, from a difference perspective, the payment logic becomes part of the agentic reasoning. The agent does not use user interfaces in the traditional sense, so there's no user that prompts any UI changes like a wallet signature or stuff like this. And the execution is considered to be fully or semi-fully autonomous. It really comes down to the implementation. You will see some implementation are by nature more, deterministic. Some are less deterministic. It really comes down to the use case. Sometimes, you can have agents that act in a very deterministic way, and sometimes you might need agents that are using some heuristics in order to come to a decision flow, and that's fine as well. Okay, so what is A2A? Essentially, A2A is a protocol that has been released by Google. So their team has been working actively on this protocol, and they made it widely available. So essentially, it is a form of communication that allows agents to communicate with each other, but also with other services via standard JSON RPC methods. It uses very structured task artifacts, which I will show you in a minute, such as progress, if a task is in progress, if a task failed, if a task succeeds. Very similar if you think about, if some of you are familiar with Redux, when you create a Redux API request, you have different states. You start with idle, pending, successful, or rejected. We can think of it in a similar manner because we save task artifacts to, get a sense of where the task is currently stored, and that is obviously very helpful. Again, agents can discover capabilities. They can search for other agents and other services that expose the card with the metadata. It shows what the capabilities are of a specific other agent in the same discoverability interface. But the same goes for resources and tools, and then essentially be able to execute the multi-step workflow, which is something that last year was all about creating chain of thoughts and multi-step workflows, and I think we are finally getting there, and that's where the agent-to-agent protocol is actually shining. In other words, think of A2A as a mechanism that turns APIs into economic actors and not just standard endpoints. So traditionally, one of the issues were that agents had difficulties find other agents, and so discoverability was the missing piece. Some of these are definitely, when MCP was first released, it started to address a lot of these issues as well, because it made the client communicate with different MCP servers, and it enabled a lot of opportunities, but it still did not enable that autonomous concept that we now see in A2A, which is something that A2A agents probably succeed in a very interesting manner. So traditionally, you can think of it this way. So agents can't pay for what they can't find. So for the agentic payment system, resources and API and tools, they must expose, the type of things that they offer, the type of things that they provide, what the price is, and how the payment to access those resources or tools actually works. So discoverability is not documentation, because it must be machine readable, it must be following a standard, and it must include payment metadata. So this is where the agent card comes in, as discovery layer. So what we use in the agent card is basically we expose the agent or the system by following the specific path pattern, and we expose a JSON object that provides information on specific metadata, such as available resources, pricing, x402 requirements, payment scheme metadata, and much more. And then what happens is that the agents themselves, they can research, they can request, scroll, compare, reason, and then decide whether they want to access, pay for a specific resource or for a specific tool or system, or even another agent with a different set of skills in order to access the data that those resources return. So if you want to put it together, think of A2A and x402 as an architecture that allows agent to discover resources via the agent card, the JSON object that I just mentioned above. And essentially, it allows agent to select resources using LLM planning, and also it enforces them to access, with the x402 protocol. And then the payments essentially happen in a very automatic manner. And whenever deemed, the agent can then retry with specific entitlement. There's no human in the loop. There's no middleman in the loop. So it's you can think of it as a very automated and autonomous way of creating an agentic ecosystem. And yeah, sorry by the way if I haven't gone into the example of the discoverability card, but I'm going to show it to you just now. Let me have a look. So one example of an agent card. So this is going to be shared with you. There's going to be a new folder called A2A. If you go to resource service and then you check your routes, there will be a new route which is called well-known route. It exposes the agent JSON card. So if you go to the controller, just a standard controller, then you can access the specific card service. And then here's an example of JSON object. So we have a name, paywall resource, we have a description, we have the URL, the host, we have the network, and then we have specific resources. So an ID, secret data, title, paywall, demo resource, URL, paywall, protocol, and settlement. And that is just one example of an agent card. Let me go back to the slides. Okay, so I also want to walk you through the demo that I've prepared for today. So the demo that we prepared, and that will be also shared with everyone after the call, is essentially a complete end-to-end A2A payment flow. At least it shows the basics to get started and how to implement it. We created a protected backend resource service. So essentially, the resource service is exactly the same as the resource service we used last week, with the only difference that we are now exposing one new route, and that's the one that I just showed you, which shows the agent card endpoint. Secondly, we use an autonomous A2A agent, which is the consumer. We're gonna have a user querying, creating a query, and then we have the autonomous agent consuming the request and then trying to access the paid resource. And then we follow the real settlement on Cronos testing. Again, like the goal is going to be to show that agents can pay other agents for resources, basically. Now we get into the architecture of everything, and I want to spend a little bit of time on this. So from an architecture perspective, think of it, we have two components. So we have the resource service, again, exactly the same as the resource service used last week, with the difference that we have that new agent card route. Express backend, x402 protected endpoints, issues for 402 challenge, and then verifies and settles payment. And then the second component is the A2A agent. And this is basically the component that treats the discoverability of resources and systems. It handles 402 responses, and it generates an EIP 3009 authorization and retries automatically. Let me go back to the documentation. All right, so what you will notice here, there is a new folder that's called A2A. I want to briefly highlight some of the architectural patterns. So the first thing that I want to show you is the structure and the roles. So we have the operator or the user, which makes a JSON RPC invocation. So what we do is we provide a query to access a specific endpoint or to get some specific data. That request is being routed to the A2A agent, which is our Python agent. It uses the agent card for discovery. We use LLM planning. We finally, use 402 handling plus payment and also retry with an X payment ID. So we have a GET request which calls the API data from the resource service, which is what's running our Express backend. We have the protected endpoints, the challenge, and also the API pay settlement flow. And so that is the most basic workflow that you can think of, this end-to-end demonstration. But there's also, if you want to deep dive, we also created the complete end-to-end sequence that illustrates how every bit and piece come together. So similar as above, like I mentioned, the user makes an RPC, JSON RPC query request that is being submitted to the AI agent. The A2A agent consumes these requests and then, tries to find the specific resources. He finds the resource service because the resource service exposes its metadata and it corresponds with the information that the M agent has identified. Then the paywall metadata is being sent back to the A2A agent. Then step number 4, we use LLM to select the target resource. Step number 5, we get the API data, we see if it's already entitled, and if the answer is yes, then we return the protected content with the 200 to 100 OK status code. However, if the request is not entitled, we will return a 402 payment required challenge back to the agent, which on the agent side is then going to create an AIP 2009 authorization payment header. We send this back to the resource, which essentially starts with the verify and settlement payment flow. And once the settlement is okay and we receive a transaction hash, we send it back. Settlement response is 200. And then at this point, the agent will be able to get the protected data, which is then being sent back to the agent. And the agent will then generate a task artifact as being completed and returned to the end user. All right, so that is the whole end-to-end flow. You can access it after demonstration as well. So it's going to be shared with everyone. And yeah, let's maybe also have a look quickly at the agent-to-agent example. So if you want to get the sense, and I'm gonna walk you, depending on how much time we have, I'm going to walk you through the code as well. But the agent-to-agent architecture is basically, you can think of it as a few relevant base files. We have the main file, which is responsible for starting the agent and, it's responsible for agent discoverability and also, task management and memory. Then we have the executor, which is basically based on the base executor file from the A2A library. So we really strongly type the tooling that is provided by the A2A framework. Then we have a pipeline PI file that is essentially responsible for the whole orchestration, the LLM planning, the agent index and resource index. And finally, we have a paywall service, which is responsible for settlement within the agent. Back to the slides. All right, so yeah, that was a brief demonstration on our architecture. Again, outlining the end-to-end flow is exactly what we saw in the diagrams. One agent is invoked via JSON RPC. Two, agent discovers resources via agent card. Three, agent request protected endpoint. Four, backend response with 402 payment requirement. Five, you have an agent that firstly parses the x402 challenge, and secondly creates the EAP 3009 authorization. And then we have a backend that settles payments via the Cronos x402 facilitator, and an agent that retries with the X payment ID, which then returns the protected content. And so again, in this example flow, there's no user interface, there's no wallet, there's no user clicks. So it's essentially just a fully autonomous and automated agent to resource workflow. I feel we kind of had to call this A2R as opposed to A2A. But yeah, the thing is, you can use agents, you can use resources. So you don't have to create a multi-agent framework. You can have one agent that is, just discovering different resources and systems. Not every system is driven by, Gen AI. Some systems are heuristics. Some systems just return, specific endpoints. So the concept here is that we create an ecosystem that is following a protocol that makes them discoverable, so that agents that actually have to do some LLM planning have the capability of discovering and searching for resources that they require. So why is this important? Because it essentially enables autonomous agents to access and purchase data. You can think of a lot of different use cases like pay-per-call AI tools, agent marketplaces, machine native software as a service pricing, real-time microtransaction, and many other things. These are just a few examples, and I think there's many more. But I think this is important because it shows that there is a key shift. So when it comes to APIs, because they are starting to become economically addressable by machines, and this is going to open a lot of opportunities within the x402, but also the agentic framework ecosystem. So yeah, I guess some of the key takeaways are obviously that x402 makes HTTP resources payable. We have agent-to-agent frameworks that finally generate a system where agents can act in an autonomous manner. It generates discoverability and also enables economic reasoning. And so together, they form the basis of what we are going to call the agent native payment infrastructure. Yeah, before going to Q&A, I want to quickly show you the repo and also the demo, and also some of the code examples so that you know how to get started, how to navigate this example. So again, you will get the full client merchant flow. We use Express and Python, Cronos testnet. It's open source. You can clone it, break it, extend it, and play around with it. And hopefully it's going to be helpful for whatever use case and project that you're building. Just remember, obviously, this is not a production ready environment, it is essentially a tutorial that you can use to learn when you build agentic frameworks. You will find this repository in our Cronos Labs / x402 example folder. It will be released today or tomorrow under the folder A2A. Actually, you can access it already now under the feature branch new A2A example, but I recommend to wait until it's available in the main branch. And I will be working on releasing it probably by the end of today or tomorrow. So just bear with us for a little longer. But yeah, demo time. So I'm gonna just show you on my console if I throw this request. So you can see this is a curl request. It makes an RPC call to our agent. So if I start to hit enter, you see that the agent is gonna start to process. I know this is hard to read, but the way this is gonna look like is you have different parts. You see that in the end, this is the last artifact. Here you can see that the artifact is final, Boolean true. So it means that this was the final step. It shows that the state has been completed. And it also shows the response of the API, paid content unlocked. This is coming from the resource, by the way, that we built last week. So this is the end-to-end demo flow. But how did this happen? So let me actually go into the repository. So what you see here is, let me actually go into the full repository file. So you will see agent to agent is the folder name. We have the resource service and the A2A service. I'm going to open the A2A service. You will find all the information on the query format, how everything works inside the README file. So the README file is probably the best place to get started to navigate. It is fully documented and should help you get started as soon as possible. So what you see here is basically, here's the example query that you can use. And it shows you all the relevant information. So this shows you how you can send information to our local host. This is where the agent is running. And yeah, so let me close these tabs and let's start with the folder architecture. So within the A2A service folder, the first folder, the core folder is called host, which is typically used for the host agent or the primary client agent. The agent that is basically responsible to consume the user request and then return, the planning. There's a few different files. So these are the core files: main, pipeline, executor, and service. And then we have a lib library folder, which essentially contains, the A2A integration for discovery and events. Then we have a core folder, which shows, the base agent, base pipeline. These are base classes. We try to strongly type them so that we can provide reusability and reproducibility as well. We created the folder for enums, common enums that are used across this example application. We used, we used both. We used Olama and OpenAI. So we just made the switch and started to use OpenAI. And so feel free to have a look. It should be straightforward. Standard OpenAI integration. It shows how to initiate the OpenAI client. And yeah, and then we have our planner. So this is where our LLM logic lives in. And as for A2A, I think this is the core for how to get started with A2A. It has our fetch agent card function, and that is what we're gonna use when we initiate the agent service. And then we have our events file. So essentially here we have the different events that we queue, similar to how we queue messages, but it helps us keep track of the artifacts. So whenever the agent needs to get some clarification, we trigger the clarification function whenever we progress. Progress means that we emit an update that is not final, and then finish is basically once the once the flow has been successful and a finish artifact is being signaled or failed, in case something fails. And that is basically some of the agent to agent event queues that we use here, to keep track of the current process. All right, then we have the base agent. That's basically just our abstract interface and lifecycle definition for our A2A agents. So, handle on start and on finish. So whenever we initiate an agent, we always pass the abstract interface of base agent. Same goes for the base pipeline, which is essentially a base interface for event-driven AI and A2A pipelines. But let's go into the relevant files. The entry point is basically the main file in here. So you see that the documentation is quite complete, and I think you will find all the answers in the code. It really explains everything in detail. It shows you how every function, every file is wired together. But yeah, so generally speaking, in the main file, this is where we, initialize our in-memory task store. And by the way, in a production environment, you probably want to use some other store, some production-ready store management that is not in memory. There is a util in the A2A library for different persistence layers, persistence options like Postgres, SQL, and stuff like this. So you can definitely extend it to production-ready memory storage. All right, so we also have a handler. This is basically, the handler that is responsible for dispatching the RPC calls that come from the executor, the agent executor, which I will show you in a minute. Or we call it paywall executor here in this specific demo. And then we also expose our agent card in here. So there's different ways of how you do it. This is not like there's no specific guideline on how you expose your agent card, as long as you follow the agent card standard that is defined in the A2A library. But how you expose it, where you put the file, this could be a YAML file, this could be a JSON object that you import and pass here. It's up to you. I think this is just to make it simple and show how it's wired together. And then the next step is we initialize. So we build the app and we mount the agent card and all relevant RPC roles in here by using A2A starlet application. And then we pass, the agent card and the HTTP handler. And finally, we build the app. And then, some configuration for running everything and making the agent accessible. We can do that by using UVcorn and start it with the UVcorn server. The next file is the executor Python file. And again, I mentioned this before, like this is implementing the agent executor interface from the A2A library. We use this, essentially to discover and access the resources that we want to query. The main function is the execution function, which is the one method that we use in order to extract the payloads from requests that come from the requests. And so you can think of it as 3 steps. So firstly, there's a user input looking like a JSON file, and we try to parse it via the JSON nodes. And then if the parsing fails, or it's empty or something like this, we then try to scan it using the context message parts for for specific parts that includes data. And then the last part is if there's no payload, we will use a fallback to default minimal payload. And then the other function in here is the cancel function. So this basically used if you want to create the cancellation of an in-flight execution. So, for example, if the current implementation is being considered as a no op and returns immediately, then we run the cancel execution. And we just return basically. As you can see, it's an empty return. And then pipeline. So here is where we progress our artifacts. So it's basically our end-to-end workflow for discovering, choosing, fetching, and reporting in the paywall agent. So it is designed to be invoked by the executor with a normalized payload. So it basically emits the progress, the update artifacts, and if the progress, we update those artifacts as I showed you previously. And in case of failure or something goes wrong, then it returns with a failure event. Then we have the asynchronous function for running, which is basically used to execute the paywall discovery and fetch the workflow. So the high-level steps in here is again, firstly we emit the planning, and then we create the discovery for progress events. Secondly, we discover agents that are provided in the discovery URL. Then we ask the planner, the LLM part, to choose the best target agent, for the query. And then number 4, we apply the choice of the LLM response to a concrete target record. And 5, we then fetch the resource via the service that does all the handling for 402 payment internally and so on and so forth. And then on success, we emit a finish event with the artifact containing the formatted text. And in case of failure, we just emit the fail event and return. So step number 1, announce planning and discovery starts. Main step, discover agent. 2, select target agent. 3, fetch resource service, the service that's responsible for payment and handling and retries. 5, emit success artifact with formatted output. And then, our central error handling in case something goes wrong. And then finally, this is where the business logic lives in. So here we basically take care of, the business logic. We have our discovery agent function, which is basically the one that finds all the relevant agents and resources. Then we have our function that applies the choice from the LLM. Once the LLM has come up with a decision, with a plan, we return it and apply it with the apply choice function. Then we have a function to fetch the resource. So this is basically used to fetch protected resources and then performing x402 settlement if required. And this is basically the one function that communicates with the resource service. Actually, here is where we implement our new Python client. So instead of having to, build the generate payment header utility ourselves, that's already available in the facilitator client. So we can just access it here. You can see this is part of our library, and then we can just see where it is. Yeah, so you can see that here we initialize the facilitator client. We pass the Cronos testnet network, and then that is the function to generate the payment header. So it's really just a few lines of code instead of having to build out the whole helper or util yourself. That should do it. And then we format the result and send it back to the agent, which is then going to return it in the artifacts when we consume the response. And with that, I think we can deep dive much longer, but just had a look at the time, so I also want to spare some time for questions. So yeah, essentially, don't worry about the code. We will share everything with you. We will share the whole repository. We will share the new libraries that we have created. And there's more updates that are coming, now and this week. There might be a few, and next week. So we're always working on some of the updates. So bear with us. The team is going to share the repositories and all the details. But yeah, here's where we are, and let me see if there's any thoughts, any questions, and anything I can pick up from the community.
Yeah, great. Thank you a lot, Rick. That was very in-depth and I think super useful for everyone, even the people who are perhaps just following along out of interest and not part of the actual hackathon. No, really, really, really cool stuff. There's one question that we have from the community and one other question. I'll start perhaps with the more generalistic one. I think you touched upon this really shortly, but what do you personally think is the single biggest benefit or the opportunity that A2A offers?
Of course. Yeah, I mean, I have expressed my thoughts a few times in the slides, right? What the I don't think there's a single. There's different fragments of opportunities here, and they can all equally grow into, really big opportunities. But if I were to choose the single most biggest opportunity, I would consider the fact that we could live in a world where we might not have to manage our subscriptions anymore, because we could just ask our agent, hey, can you periodically just check what am I using, what am I not using? Because I personally I spend quite a significant amount every year on subscriptions that I never use. I used it maybe once and I forgot to cancel the subscription, and then I just move on and live, and I don't check my bank statements for subscriptions. So imagine having an agent that runs 24/7 and make sure that you don't pay for stuff that you don't use anymore. That's one pain point, and by all means, everyone might have different pain points. But what I'm trying to say is that we can enable ways that will help us to save and automate on processes that we would personally never do ourselves. And so I think that is one thing. Secondly, because now the question is really specific to A2A. We have MCP realities, we have different agentic framework realities. I don't think there is one framework that is better than the others. I think we are in a point of time that every framework is, developing and establishing itself, and only time will tell which one will be the best framework to use. For today, in 2026, 2025, 2026, I believe that the agent-to-agent protocol does enable something that traditional MCP systems might be struggling with, and that is the ability to search and discover for services autonomously for as long as services and resources are discoverable. Think about getting information, getting access to different agents. Imagine an agent being able to hire a different agent for a specific service, and then autonomously getting whatever he needs back from that agent without having to ask a human. I think that is quite fascinating, and we are still very early, so I think there's still going to happen a lot. And I don't know which framework is going to prevail and which not, because only time will tell. But I think today I feel quite happy and excited about A2A personally, and it's subjective. But I think in the context of x402, there's a lot of synergy between, as you could see from the demo, between using x402 methods and the A2A framework, because the A2A framework enables agents to be discoverable, but also to discover resources that are available. So this could be, imagine a marketplace with resources. Some can be private, some can be public. In the case they're public, they can be searched by other agents. So whatever you are building, that agent could use a public endpoint to access discoverable services and agents and start to create autonomous workflows with them, whatever the use case might be. And I think that is something that I personally feel excited about.
Yeah. All right. Great answer. That's going to go in the highlight reels for sure. We got a question from the community as well. Rick, I'm going to send it over to you on Slack really quick because it's quite a long one. And I think if I'm just going to read it to you, it might be a lot. I'll just read it out loud for everyone on the live stream. The question is, how does Cronos plan to ensure standardization and discoverability of paid AI agents while avoiding fragmentation across different protocols and blockchains?
Yeah, I love the question. That's basically
means probably a lot more to you than it does to me. Yeah, go.
Yeah. I love it because that's the kind of issues that keep me awake at night. So fragmentations, not being able to create standard processes is a big problem. I believe, and we're already doing this, by generating a protocol and following standard practices that enable multi-network communication. That is going to be the first step. So we need to have standard schemas. So the schemas need to be working in all the different chains. I think of it this way. When blockchains were created, you had different standards. We have the EVM standard, for Ethereum native blockchains. They all work great together. But then you started to have, the Solana standard, different standards, the Cosmos standards and whatnot, which need interoperability, which is one of the biggest issues in blockchain right now, is that not every chain is natively interoperable.
Yeah,
exactly. And the same issues. So this is why standardization is super important. We need to make sure that the schemas, the interfaces, everything follows a standard that works across other chains as well. When we are able, and we are following, so when we build the facilitator and the documentation, we didn't try to reinvent the wheel. we try to follow what has been already widely accepted, in other chains. And that is the standard that we should follow, because when we have schemas that can be reused across different chains, then that is going to enable reproducibility and standardization, because it's really important for us to have schemas that work across chains. I'm not saying that we are going to start, our facilitator is Cronos native. It's not Ethereum native, or it does not, or at least for now, we don't have support for other chains. However, that does not mean that you cannot build your agent-to-agent protocol and have it communicate with different facilitators. Because if you look at this, different facilitators for Base, there's facilitators for Solana, and despite using different chains, they all follow the same standard, which means that on the integration side of things, on the agent-to-agent or whatever agent framework someone is using, they don't have to create different integrations. They might have to use different libraries if they want to use libraries, or they might, if they want to build out a feature themselves, the integration module themselves, then they might standardize it in a way that works across different chains. But I think as long as the schemas are different, they don't have to sort of, change the JSON object format. I think it really comes down to that, being consistent in schemas, being consistent in what is requested, the request and the responses. As long as we are consistent in those dynamics, in those universes, then we will be able to provide the reproducibility and standardization, following consistent patterns that are applicable across different implementations.
Okay, great answer. Yeah, I love that it also sparked something in you. Then it's a great question from someone in the chat during the live stream, actually, that we picked up. So that's great.
Yeah, definitely.
Let me check if we have any more questions. Otherwise, no, I don't think we have any more questions at the moment. Yeah, Rick, once again, thank you so much, right, for sharing all your knowledge, taking the time and effort to take us through all of this content, basically, right? I'm sure it's super valuable to everyone involved. Thank you all for joining today, by the way. We had quite a lot of people joining, a lot of views here. As we've mentioned, we will drop all the links and the resources after this workshop, including the link, again, to the Hackathon Telegram channel. As I've mentioned before, we'll also upload the full live stream on our YouTube, so we can sift through it again and rewatch any segments that you find interesting, or the whole live stream, obviously. And I think that leaves it for today. That's it for today, I think. Let me check one last time. Yep, I think that's it, guys. So once again, thank you, Rick. Thank you to the Crow fam for showing up. And I would say I have a great rest of the day, everyone. And thank you again. See you next time.
Thanks for having me. Thanks.
Thank you, Rick. Bye. See you, everyone.